Hi guys, Shouvik here. Today we'll solve another beautiful questions from Leetcode itself. It is of day 8 of our 100 days of coding challenge. Today's question is alternating groups 2. Let's before we jump on the question, that is about this question, that is I personally felt it is not a medium level question. It is more than a medium level questions. Like if we consider on an interview perspective, and if we have to solve in that particular time durations of 30 to 45 minutes, then there are basically bunch of cases you have to consider before you are going to come on the very optimal solutions. Now let's get started on the question. So on that question, we have given there is a circle of red and blue tiles. So a circular ring is basically given to us, and every elements of the circular ring is either red colors or blue colors. And you are given an integer array colors and an integer k. The color of the tiles I is represents the colors by colors equals colors of I. So it is very straightforward. Like we are given a colors list where colors of I, if it is 0, then that means that is a red cells, and if it is a 1, then that means that is a blue cells. And but that is, this colors is not a like a straight array. It is a looped array. So this 0 is basically linked with this 0. So if I point it out, so basically this 0, so the last elements of this array is basically the first linked with the first element. So after 0, it is going back to this 0 1 like this. So that is a circular array altogether, so we have to say, because it is mentioned here only. Now because it is mentioned there is a circle, it is a circular array altogether. Now what we have to do, an alternating group is every k contiguous tiles in the circles with alternating colors. So now within the circular array, we have to find a group of k elements, a group of k elements, group of contiguous k elements. Contiguous means the sub-array type of things. Like if I consider 1, then its contiguous part is 0 1 like this. But if I consider starting from 1, then skipping this 0, if I propose I will take this one, that is not a contiguous. So contiguous means continue memory allocated elements from the array if we are choosing, right? Now each tiles in the groups except the first and the last one has a different colors from left and right tiles. So as it is a circular kind of thing, so if I standing at colors I, if I proposing you like this is our one of our answer group of k elements. Here k equals to 3, so I am proposing that is an group for which there is an answer possible, like from starting from this 1 till this 101. Now what it is mentioning on this last line, like each tile in the group, so each tile in this group except the first and last one has a different colors from its left and right tile. So if it is a first tile, if for our case this one is the first tile, then we don't have to bother about who is of its left, because we are starting from here. So and similar for like right, so we don't have to bother what it's on its right, because we are ending at here. But for every between elements, which is basically in between our left and right boundary, like one example is this 0. So for them the adjacent guys means like very left and it's very right should have the different colors what it is holding. So this is holding color 0, so its left should hold color 1. So these zeros left is holding color 1, and these zeros right is holding color 1, so which is not equal color. So that means we have to find similar type of sequence where in between elements have alternating colors, and for terminals we don't have to consider, and the left and right we don't have to consider because they are the very start. So if it is start, then we don't have to consider this, and if it is a very end, then we don't have to consider what is after that. And why we don't have to consider what is previous of them, because previous is going to be valid by intermediate elements. So if I am considering if one's previous is an alternate color of 1, so one's alternate is 0, so if its previous as the alternate color, it is bound to be, because if that is our valid group, so in between elements will make sure that its right and left should have different colors. And if we are building similar this way, so start and end is going to be automatically fulfilled with the conditions. I think that is very intuitive, you guys are getting these things. So now return the number of alternating groups we can build. So now we have to return the alternating groups, like one example that I saw that I highlighted you here. So that is one group. So now we have to find how many alternating groups are there. Note that since color represents in a circle, the first and the last tiles are considered to be next of each other. So that I mentioned already, the first and last tiles we don't have to consider if it is a valid first and last tiles, because if all the intermediate tiles are fulfilling the conditions which is mentioned there, then first and last is going to be automatically fulfill the conditions, because their previous first we don't have to consider, last just its last we don't have to consider. As simple as that. Yeah. Now if we can see on the constraint part, so I will jump on the test cases. So on the constraint you can see that the constraint is very big, that is of 10 to the power 5. So yeah, so what is the brute, before we start, what is the brute you guys are thinking from here? If I can just iterate you to a test case, so that is the circular ring is given. So in the circular ring 0, 1, 2, 3, 4, that is the index of the colors array. And here if k equals to 3, they are giving the output as 3. How 3 is going to be possible? Because if we start from 0, then from 0, 0, 1, 2 is a 1 k groups, satisfied k groups. Starting from 1, 1, 2, 3 is another satisfying k groups. Starting for 2, 2, 3, 4, another satisfying k groups. Like this way we have answer equals to 3. But if you start from 3, 3, 4, 0 is not a satisfying k groups, because 3, 4, 0, now 4 and 0 have same adjacent colors. So that means we are violating the condition. So considering 3, 4, 0, we don't have any answer. Considering 4 as a starting point, 4, 0, 1, we don't have any answer, because 4 and 0 have similar color. Yeah, and for 0, so we have already calculated. Like this way, one solutions that you can write, that would be very simple. Like starting from every elements, if you should be iterating from I equals to 0, and we will go till I equals to n, and there is a j loop we are going to run. Let me write the pseudocode, that would be maybe put the exact what I am trying to say to your brain exactly. Yeah, so what I am proposing, I will run a for loop for I till n, and I will run another nested for loop. This for loop is going to be start from j equals to I plus 1, and we will run it till how many times? So we will start from I plus 1. J will start from I plus 1, and its size should be let not write on the j loop, then because we just have to run it 2k times. Yeah, and another things that I just want to mention you, that if you can see the another constraint, so on this another constraint you can see that our k is always in the range of colors dot length. So if your colors length is given to you 5, then that is never, the question will never going to ask to find a k group elements of size 6, 7, 8 which is more than 5. That is never is going to be a case. Yeah, now where we are. So let's start our iterations from, yeah, this we will run to for sure I starting from n minus 1 we will run it, starting from 0 we will run it to n minus 1, and we will start a j loop. J loop will start from I plus 1, and we will run a while what? While of this should run at k times, right? This loop should run k times, because we have to find a k consecutive elements, k consecutive elements where the conditions is also going to be satisfied. So on that case, we can state count we can start it with k, and while count, so that means we have to run this loop while we have some count, and if we have that count, then we have to check if my colors of j not equals to, that is j, colors of j minus 1, if that is the case, then we can do a j plus plus and j plus plus, and we will decrease our counter to minus minus. Yes, like this way. If it is not means like we are not able to basically else, on the else block just break it out, and here you can take a boolean altogether. Here you can also, like, before breaking make your OK as false, and after that just do a break from here altogether, then do a break, and initially here somewhere take some OK also, OK equals to true. So that means we are able to, so this boolean basically vending you the information. Starting from this we are able to build our answer, right? And if that is so, then outside of this loop, if our OK is set, then we can say starting from I, we are able to build a key group elements. Then just do answer plus plus. Yeah, and after the outer for loop, just return your answer. Yes, that's it. I think that is very straightforward. But yeah, the time complexity on this case, this loop is going to be run of a time complexity of big O of n. And starting from here, we are iterating another for loop which can go not while loop which can go at a complexity of big O of k. So our time complexity is going to be for this solution is big O of n cross k. Now it is a valid solution as per the constraint. Yeah. So constraint stating n can be colors of length can be as big as 10 to the power 5 and k can be as big as colors dot length. So that means that is going to be a 10 to the power 5 cross, that is boiled down to a 10 raised to the power 5 cross 10 raised to the power 5 of complexity, that is of 10 raised to the power 10, which is going to be a TLE for sure. You are getting a TLE. Now, but within the brute force you have to figure out a solution, because there must be some redundant case on previous days question also. It is more kindly I found, if you don't if you still didn't check it out our previous days solution, please do the last video also. There we have initially wrote a brute force solution, and from brute force we got the intuitions how to optimize the solution. And if we didn't check it, please do check it our last video solution. That is let me just give you what it is, these questions more specifically. This one, you can go to our channel, and after that, yeah, if you are going to our channel, please do subscribe on the same go. That is so you are not going to miss any important updates. Yeah, this video, the minimum recolors to get key consecutive black blocks. I will make a link of this video in the comment sections of this video also. But yeah, please do check it out. Here also we have discussed 3 approaches, and from brute to better to optimal we have wrote three approaches and 3 different how like every solutions is going to propose what we have to do to reach to the next optimal solution. We have explained details. Please do check it out. That will help you to solve this question as well. Yeah, now let's go back to the today's question. Yeah, now on the today's questions, so that is the for sure you got the intuitions. There is a brute solutions we just written, which is obviously going to be work from 10 cube complex 10 cube of constant, but not for our case. Now what actually we are doing, we are actually doing, if we are standing to a particular index, let's suppose if we are standing at a particular index, so we just have to check. Let's take any arbitrary example. Let's take this bigger example. So if we are standing at 3, then what we are interested for? Hey, I am starting at index 3. From index 3, what is the length of our alternate sequence? Starting at 3, what is the length of our alternate sequence? Starting at 3, how you can expand your alternate sequence length? That if we have that answer for every index. So let's suppose if we are standing at 2, what is the length of the alternate sequence starting from 2? That is itself altogether, because from 3, 2, 3, 4, if we are just try to go to 2 and then 3 is the same color, we are not able to go. So we are not going to expand or size 2 at least, considering starting from 2. But if you are starting from 3, okay, from starting 3, 4 is my adjacent, who is different color, okay. After 4, 5 is a different color. From 5, 6 is a different color. From 6, okay, now it is a circular concept is coming. So from 6, we are going back to 0. 0 is a different color. So from 0, 1 is a different color. So I am just giving you the thoughts, how in an interview, how you have to think to a problem so that you can reach to a solution. So I am just trying to make your thinking process, like thinking ability to expand, because if I am just iterating to my code, then you can just you can do that things. You can just memorize the code, and you can, maybe if this exact question is going to be asked to an interview, then maybe you are able to solve that question. But if there is a slight tweak in this question, if your thinking ability is not going to be elaborated, not going to be expanded, not going to be mature, then you are not able to handle any interview question. Because on interview there is never ever I have faced any copy pasted question. Never ever, no interviewer asked any ever copy pasted question. They always make a tweak on that question. Top of that, they will give you that question. So always try to, I'm just giving you how I have think to a particular solution, because we just wrote a n cross k solution. So what we are doing at the n cross solution, we are doing starting from a particular index, how much we can expand. Starting from a particular index, how much we can expand. So that's what we have done on our brute. Now if I give you, now for every index, do you need to expand till k? No, right? Because if considering that this particular index, considering from 3, if you are able to expand, if you are able to expand 3 4 5 3, let's suppose, let me give write it down in the here altogether. Yeah, so I am giving you, if अरे यार ये यार बहुत झमेला करता है. Now if I draw a circles, these, there are 0 1 2 3 4 5 6 7, right? Now if I tell you, like, if from considering 2 you are able to expand of a size of 5, because let's suppose 5 and 6 have same color, 5 and 6 has same color, so starting from 2 you are able to expand 5. Starting from 2 you are able to expand 5. Do you need to again start from 3 and try to expand? Do you so? No, right? So if starting from 2 you are able to expand till 5, then what is the size we are able to build till now? So the size here is, the size we are able to build is 2 3 4 5, that is of size 4. Now let's consider k equals to 2. K equals to 2 means what? K equals to 2. Now you should be always think about on a mathematical perspective, can we do something better? Like our next sequence is going to be starting from 3, right? And here we are able to expand. Don't focus on k on the initial go. Try to expand from a particular index. Try to expand as much as you can. So here k equals to 2, but I am not stick on k equals to 2. So if you on the previous brute force solutions, if you are trying to expand of k equals to 2, then from 2 you will expand 2 3. Okay, we got that k equals to 2, like 2 different adjacent guys. We are satisfied. Then we are check from 3. But here on the optimal solution we don't have to do so, because that is basically giving you the multiple like cross n cross k type of complexity. But if you are expanding at as much as possible from a particular index, then from 2 you are expanding till 5, from 2 you are expanding from 5. So that means there is a sequence starting from 2, 2 3 can be a possible answer, 3 4 can be a possible answer, 4 5 can be a possible answer. So how many possible answers you got on this? 2 3 3 4 4 5. So that means if you are able to expand of size where size is greater than your k, यार एक तो बोर्ड बहुत छोटा है, इसमें आता है दिक्कत. If your size is greater than k, greater than or equals to k, then how many, here there is a very good mathematics. Then just think about, pause the video for 1 to 2 minutes, think about that. If your size is greater than k, so for our case size is, we got 4, our k is given as 2, so that means there are 4 elements. So if so now anyone is asked you how many consecutive elements of a group of 4 elements you can choose. So from very start you can choose 2, just after that index you can again choose 2, just after that index you can again choose 2. Like this way you are going to able to add your answer size minus k plus 1. Just write it some cases and do some mathematics on your own, then you are going to get. So our case is 4 minus 2 plus 1, so that means 3. So because how many elements with a at last of so the very last elements should have a gap of k, right? The very last elements is what? The very last elements we are able to choose a 4, and considering 4 we should have a gap of 2 at least. So 4 5 there is a gap of 2. So now from 2 to 4 how much we have to come? From 2 to 4, so that many elements we are able to build. So now that is what? That is actually your size. So your size you are stating as 5. Your size you are stating as 5. So 5 minus k, just go back, just make a gap of, so here, so your size is still here. Now make a gap of 2 here. Now make a gap of 2 here. 5 minus 4 is 2. Now from here you are plus 1. So that means if you are standing to, if you are coming till these points, that is the last points where you are able to choose k elements, because after that we if our k is 2, then starting from 5 we don't have the liberty to choose 2 elements, choose k elements. Starting from 5 we don't have the liberty to choose k elements altogether. So the last correct index is size minus k. Size is 5, size is 1 2 3 4, size is 4, 4 minus 2, 4 1 2 3 4, 4 minus 2, we have to make a difference of 4. 4 minus 2 is 2, 2 plus 1, 2 plus 1, so 2 plus 1, so that means we are able to 4 minus 2, so that means that should be the gap. So the gap is of 2 plus 1, so 2 plus 1 is 3. So that's the reasons we are able to put 2 3 3 4 and 4 5. Just make a like diagrams on your pen and paper, and just try to iterate of multiple cases. You will definitely get this. I am trying to explain my best, but yeah, until you start with pen and paper and you are not able to solve this mathematical question altogether. I almost took 30 to 45 minutes of pen paper working. After that, I am jump on that particular intuition. Please do until that is just you are seeing that video and you are not getting anything, because that is not a memorization question. That is altogether how much you can dirtify your hands with pen and paper. You have to do that, so that then only you can get the intuitions. So that is the formula we are able to build for that particular question. Yeah. Now let's go ahead. Okay, let's go on the code, and if we can try to fit this particular formula to our question. Just try to think on that. Yeah, I will come on that particular part a little later. So basically, this below code is holding the value when there is a circle exist. So if there is a circle exist, then we have to perform few extra job to our for this particular question. But if there is no circle, then we are good. Then no circle means how you can determine there is a no circle. The first elements and the last elements has similar color. The first elements of the array and the last elements of the array has same color. So first element is 0 and last element is 1. So both have same color. So that's what I written here. So if first element and last elements has a different color, that means there is a circle. And for the circle, I am coming. What is the extra handling we have to do? I will come on that. Yeah. Now first skip on the circle. If consider there is no circle exist altogether in our question. So that is a very simple question. That the list is basically a non-looping list. So that is a single looping list, because you will never ever jump on the loop cases, because the very first and the very last elements have the same color. Yeah. Now let's handle the easy case. If we will start I equals to 0 and our size is initially at 1, and we will iterating I plus 1 less than equals to n, and we will very TDL case. If our colors of I not equals to colors of I plus 1, because the two adjacent basically not going to be of same color, then we are increasing our size. And if they are so, if our two adjacent cells has the same color, so that means we got a group of size, whatever the group, we have to consider that is a singleton group. We not able to carry forward that group altogether, because both of the elements. So here, if we are starting from 0, 1, 2, then 2 and 3 has the same color. Then starting from 0, 1, 2, we are not able. We already have a size 1, 2, 3, and from 3 we are not. After 2, we are not able to expand because both have same color. So from 3, let's start a very fresh. Let's start a very fresh ring building or like grouping all together. So that's what we have to do. If both are different color, then we are increasing our size, and if both are same on the else block, then the cases that we have just seen on pen and paper. If size is greater than equals to k, then we have to do answer update. Then we are going to update our answer size minus k plus 1. Exactly similar things what I have just written on the OneNote, and just I have explained to you guys. And yeah, and if it is not as there is a breakage points, we are again reset our size to 1, that I just explained to you, because we are not able to expand whatever the size we have. We just have to make a very fresh start from that particular point. So from this particular index, we are making size again reset to 1, because our size reset is we are considering size reset to 1 only. So we are considering from that particular index, let's make a size equals to 1. Cool. Now it is the case where basically there is a OK is going to be true only when there is a ring altogether exist. There is a ring altogether exist, like circular things is altogether exist. Yeah, let's not jump on this OK true cases. I will explain you. But yeah, let's first complete with the single one dimensional array. One dimensional means there is no circular things is altogether happen. So I will explain this case. But yeah, let's on the first go, let's not consider this. That will then again make you on the wrong side. But yeah, just try to break your think process. So by explaining these questions in a very detailed way, what I am giving you, how to break your solution to a multiple independent components. If we don't have a circle, let's solve it independently. Then we will consider if there is a circle exists, what is the add-ons we have to add. Then we will going to consider. But if you try to make your brain a very headache conditions, like you are trying to solve if there is a circle, if there is not a circle, if there is a circle exists, what is the extra handlings we have to add. If you are trying to solve everything at the same go, then you are not able to come to the you might be going to be come to the solutions, but that is not the correct way you have to think, and notice that is not the correct way you have to also explain to the interviewer. Try to explain to the interviewer as granular as possible. So that is the way I am explaining. So I initially told you guys that we will consider the case if there is a circle exists. Let's first solve if there is not a circle exists. If there is not a circle exists, that is a very simple 1D non-looping array question. So let's first solve it for a 1D non-looping array case. I will come on the OK case later. So you can explain the same things to the interviewer. Yeah, and if size is greater than equals to k, again, so why size is greater than k? Let's suppose you, let me just quickly explain these things. So that means you have 1, 2, 3, 4, 5, 6. Let's suppose till this, that is of what can I say, that is of red, blue, and after that you are coming to this, and after this you don't have to go further. So red, blue, red, blue, red, blue, something like this, red, blue, red, blue, red, blue. You have this array, and what is your size after the iterations? Your size is 1, 2, 3, 4, 5, 6. Your size is 6. So that means these things, that is also a very critical case. So that you be take a very eagle eye on this case, because you are going to update your answer when there is a breakage case altogether. So breakage case means if it is not a, instead of it is a blue, if it is a red, then that means that is a breakage case altogether. And if it is a breakage case, then our answer is going to be updated for this particular segment. But what's about this particular case? Because because our loop is going to be ended, because we are not able to expand I after this, but we have calculated something of valid groups, right? So for these valid groups, let's consider the answer. So that's the reasons you have to do these things. If your size after these iterations is altogether exists, so that means there is a the breakage things we have considered of within this loop. But if there is no breakage, or if there can be breakage, but we after loop completion we have some size, if that is the case, then also we have to update our answer. And updating our answer, I already explained to you, size minus k plus 1. That's the way you have to update your answer. Yeah, that's all about if it is a non-circular array. Non-circular array, then you should be good till this point. But if it is, as it is a circular array, then you have to do some more rigorous task to this question. Yeah. So how you can determine if there is a circle exists? I just told you the first elements and the very last element should have a different color. So if they have different color, then what? Then we are trying to expand from starting index as much. Starting index is going to be start from 0 and end index is going to be start from n minus 1, that is of last elements. We are trying to again enlarging. Our concept is fixed, right? Our concept that I have explained you, we will try to enlarge at max as we can go. So from I equals to 0, we are again going to enlarge, like how far from I equals to 0, how far I can go, how far, starting from 0, how far I can go, from 0, 1, 2. So this loop starting from 0, it can expand 0, 1, 2, this point, because after that is a similar elements is going to be we are hitting. So our first loop is going to be breaks. I did the exact same things. Initial, just do, because we are encountered with a circle. So just make your OK as true, because we need this on our future calculations. So just make your OK is true. And after that, try to expand your I as much as you can. If colors of I not equals to colors of I plus 1, then please do I update. I plus equals to 1. And if it is so, if the colors are same, then break it out. And same things, let's do for J. We are starting J equals to 6. Please follow my cursor. We are starting from J equals to 6. And we are again doing a back iterations until when we are considered a partial ring. Till I points. Now from J points, we have to run greater than I. Because till I we have already considered. Now let's try to run greater than I. So that's the reasons we are running if j minus 1 greater than I. And the same things, if colors of j not equals to colors of j minus 1, we are negative out our j. We are going like from 6, 5, 4. We are going something like this. And if they are same, then we are breaking it out. So if you do your job till these points, then you are in a good state of pinpoint what is the starting of your circle, considering what is the starting of your circle of that particular circular array. What is the starting of your circle? So your starting of your circle should be, so from, because you are getting right here we have that junction, so here we are stating that both are different. So that's the reasons we are expanding from here how far we can go, from here how far we can go. And what is the starting point? From here till this, from j till I. So j is at 4, from j till 2. From j till 2 we are going to expand, considering there is a circle exists of first and last elements. What is first? First is 0, last is 6. So considering first and last, we are able to expand starting at j. J is point to this particular index 4 to index I is starting pointing to index 2. So that's the reasons I have making our start is j and our end is I. Our start is j, that is 4, and our end is I. I am repeating these lines to you guys because that is actually the brain of this question. Like this way you have to think of a particular question. I'm just making, I can explain this video within 1 to 2 minutes, but that is not going to help you at all in the long run, because on the long runs you have to mature your brain to a problem solving, because how you have to approach to a particular problem, that logic building skills I want to improve to you guys. Yeah, just give me 2 minutes. My charge is going to be down. I'm just coming in 2 minutes. Okay guys, I am back. Let me put the charge. Okay. Yeah, let's continue. So we got our I and J, start and end at the correct point. Now there is a case. So that is a very trivial case that I have found out. So I written it down here. But mostly I think that also can be handled later. But yeah, the first things that I told you, make your code as granular as possible. See if you find any edge cases, maybe that can be handled by our below okay level handling. Okay means there is a circle handling. But yeah, I very like if there is an edge case on a granular levels, you are able to identify, just do a return. If you are sure about we can do a return from there is no further calculations for that particular block, then do so, because that is basically helping you. If there is an unwanted edge case exists, we have already done the computation for that particular case. Yeah, so this is basically if our start and end is going to be point at same, so that means expanding. So starting from there is a circle, there is a circular loop to for sure exist, because that's the reasons our very first and very last are non-identical. So from circle, from the junction point, we are going back to a particular index where start and end are same. Is it meaning something to you guys? Let me draw a quick diagram then. So I am stating we are starting 0, 1, 2, 3, 4, 5. Let's suppose that is our circular loop, and I am telling, hey, this 0 and 5 has a different colors, and you start your J from here, and you have started your I from here, and you have started your I from here, and from here you are able to expand till 3, and from J you are able to expand at 3. So that's the reasons you start and end as lying in the particular index. So is there any observations? So that means please draw if that is a red, blue, red, blue, red, blue. So that means that is going to be another one. So that red, let me draw another ones. रेड, इसमें जगह बहुत छोटा हो जाता है, ये दिक्कत है इसका. रेड ब्लू, रेड ब्लू, रेड ब्लू. Yeah, let's consider this. So that means from particular red, so that 1, 2, 3, 4, 5, 6. So that means there is an even length. If your start and end is going to be point, your start is here and your end is also there. So that means considering starting from these particular indexes, we are going to land on a particular index where start and end both are same. So that means there is a circle exists of 1, 2, 3, 4, 5, 6, that is of even length. So that means our entire circular array is an alternate sequence of even length. What it is signifies then? If that is so, then can you say, like, starting from every elements you are able to build of k group, because your k is less than of colors length, less than equals to colors length, that is given to the constant. So starting from every index you are able to make a group of k elements. Starting from every elements, you are starting from very last elements also by the circular way, you are able to build a group of k elements. Can we say that? I think so, right? Because we have a circular ring of even length and every elements are of alternate color, and if that is so, we are very good state. Starting from every element, we are able to build up a size of k group, distinct consecutive group of colors group, which is given to the question. Yeah, we are able to build so. So then can we say our answer should be directly of n? How many elements to our circular array? starting from every elements we are able to make of group k elements. So can we return our answer equals to k? That's exactly what I did. If our start and end is point to particular index, and if first and last elements is also going to be of a different color, so that means there is a circle exists, and considering that circle we are land on a particular point, so start and end are same, so that means there is an even length circle exists of alternating color, and if that is so, then we are good on the state of returning what is the n is given to us. So n is nothing but the length of the color list. And if it is not, then can we say so for what for intermediary things too we are good. So for intermediary things too we are good. So for that means from starting from a particular index, it is able to expand till this point, and after that it is breaked out. So that means the circular case is altogether not hit, because the circular case is altogether hit if I landing at, if I plus 1 is going to be again the zeroth elements. So I plus 1 less than n. So I plus 1 is going by the circle, it is going to the first element. So that means if we have some, so this answer is never going to be hit, because that is breakage intermediary. If there is a breakage intermediary not on the circular path, then we are good. What is the answer we got? We are good with this. But if it is not, if we are carrying some answer considering to a particular index till last index. So this size, basically if you have some size, so that's the reasons I have made some vigorous printing of what is going to be size is going to be updated. So if your size is still exists, so that means there is a breakage, there can be a breakage, there cannot be a breakage, but you have, after these iterations, you have, let's suppose 3, 4, any size of alternating groups in your hand. Now by the principle of circulations, what is the extra size we can expand, because this for loop is not going to be operating on a circular manner, and if you are operating in a circular manner, then again you are going to be of n cross k complexity. So just to remove the n cross k complexity, we have pointed out our start and end pointers, so we are not going to recalculate. Okay, so from very last to we reached, and from very last let's again move in the circular manner. How far we can reach we don't need, because we have already calculated fit our end pointer. So our end pointer basically tell you starting from 0th index how far you are able to expand. So that is our I, and we have set our end to our I. So if that is so, if your OK is set, so that means there is a circular alternating sequence exists, and you have some size to your hand. So why not you are feeding this size with what is n plus 1. So that means if your end is pointing to 2, so from 0, 1, 2, so that means that is a zero based index. So you have more to grow. You have the liability to more to grow of n plus 1 size. So you can go more n plus 1 size. So your size should be not size. Please increase yourself with n plus 1. Why n plus 1? Because end is basically a zero indexed where our end pointer is lying. So how many elements? Elements should be, as it is a zero index plus 1. So that means end plus 1. So if our end is standing at 2, so starting from 0 we are covered to 2. So 0, 1, 2, that means 3. So end is pointing to 2, 2 means n plus 1. So we have to add n plus 1 more elements to our answer. So let's do that. So we have increased our answer. And again on the calculations we did the same things. There is no change. We already seen this. So for a particular, if we are populating with some size elements, and if there is more by OK, you have some, there is a circle exists, then please append more ends to your size, and answer is going to be calculated on the same manner. But here is a small catch exists. So that is a very critical edge case, I have to say. Yeah, I also initially missed these edge cases, frankly speaking, but yeah, let's try to understand what it is stating. So the thing is, what you are doing, let me again write it down, then only you are able to get this. So we have a ring 0, 1, 0, 1, 2, 3, 4, 5, 6, 6, 7. Let's suppose we have this ring. So we are stating, let's suppose from 6 we are able to expand till 6 and 7. We are not going to expand till circular way, because circle is going to be handled by the initial handling. We have already fit our end pointer. So we just have to expand till our till the last. How many we are able to expand? We are able to expand 6 and 7 of size equals to 2. 6 and 7. We are expand till 2 size, 6 and 7. Now if there is a circle, so that means your OK is going to be set. Then OK is stating, starting from here, you have the liability to expand till index 4. So that means 7. How you can know this and these are of different colors? This is going to be vended over your OK variable. So that means there is a circle exists. So from 7 you have a liability. Your size is not going to be 2 only. Starting from 2, you don't have the liability to expand till 2. You have the liability to expand till 4 in the circular manner. So that means again n plus 1. N plus 1 is what? 0, 1, 2, 3, 4. So 4 plus 1, that means 5. So there is 1, 2, 3, 4, 5. So these 5 more extra elements, you have the liability to expand. So 5 plus 2. So your actual size is going to be at int plus 1. So if it is a, then your actual size is going to be boiled down to 2 plus 5, that is of 7. So that is your liability. But there is a catch. We already have considered this particular group. So what we are stating, so size minus k plus 1, if you remember, we are stating 6, 7, starting from 6, 7 dot of size 6 plus k we have expand. That is one group. Now 7 to dot 7, then 0 elements, then dot, then again of size of k groups. Then starting from 0 dot 0, 1, 2 dot of size of k groups. But this 0, 1, 2 to your k groups is already handled. So if you do a direct answer add, you are going to add extra things. How this is going to be add your answer? That is going to be add to your answer by this internal breakage. If there is an internal breakage is there on that particular questions, then that means from 0, so we have already considered from 0, if there is a size of k group exists, then we have already updated to this internal breakage, because we are starting our I from very 0. So what is the extra? So from starting, what is the extra we are adding? So but please be sure that is only, so these extra efforts we only have to consider if there is a circle exists. So how we can consider if there is a circle exists? By our OK variables. So if there is an OK set, and then we have to find how from starting, how many, starting means from 0, how many, like from 0 to k, from 1 to again of chunk of k, from 2 to k, how many extra we are going to be already pre-calculated. If so, that we have to just negate from your answer, final answer. So yeah, from we have initialized our from starting as 0, and how many extra means our end plus 1. So end plus 1 basically giving us where actually our end is going to be pointing. So if I giving you example of this particular question, particular test case, so here you can see this one, yeah, this one is the correct one, yeah. So our end is pointing to 2, and so and our k is given to us as a 6. So starting from end plus 1, so end plus 1, give me 1 minute. I think I have written it somewhere. Let me bring, that is not the test cases why it is breaking. Give me 1 minute. Yeah, I'm back, guys. So the thing is, I think I have written these test cases. Yeah, this is the test cases. 0, 1, 0, 1, 0, 1, 0, 0, 1 of size 1, 2, 3, 4, 5, 6, 7, 8, and we have to consider a size of k equals to 6. That is one, correct. That is one. So if I am trying to draw this of size a, size of 8, starting with what? Starting, I think we have started it with 0 only. Not this. Starting with 0, 0, 1, 0, 1, 0, 1, 1, 2, 3, 4, 5. Then not these test cases also. I think that is the last test case where we got stuck here. This one mostly. Let me draw the diagram. 0, 1, 0, 1, 0, 0, 1. 0, 0, 1, 0, 0, 1. Yeah, not these guys, this one. So we have given k equals to 2 on this particular case mostly. Sorry, remembered. No, k equals to 3 is given to us. K equals to 3 is given to us. So our start is going to be point 0, 1, 0. That is our start. And our end is going to be point. Why it is going to be point? Here 1, 0 here. Sorry, that is our start and that is our end, right? So a start is always starting from the very last, so that is our very last, and that is our very first, that is our very first, that is our very last. So from this we are expand till this 0, 1, 0, so that is our end, so that is our end, and this is our start. So from here we are able to expand till this. Now if we have a k equals to 3, now if we have k equals to 3, now what is the case? So we have already calculated answer for 0, 1, 0, and what we are carrying? We are carrying 0, 1. So our initial size was of 2, and as it is a circle, then we are added what? K 0, 1, 0, that is end plus 1. End is going to be standard 0, 1, 2. So our size is going to be of 3. So here basically considering the end is going to be 3, and here we have size of 0, 1, that is of size 2. So our final size is going to be 5. So now we are stating that starting from 0, you can expand 0, 1, 0, you can expand 1, 0, 1, and you can expand 0, 1, 0, 0, 1, 0, but this expansion that is of 0, 1, 0, so that's the reason now we are adding to size minus k plus 1. So that means we are again considered that 0, 1, 0 expansion, but 0, 1, 0 expansions is already handled by another loop, which I already explained to you guys, that is of internal breakage. If there is an internal breakage on here, this particular loop is, this particular answer is altogether calculated from here. So what we have extra here, so our end, so let me again draw you for you guys, because that is for explanation purpose it is going to be an hazy. 0, 1, then 0, 1, then 0, 0, 1, right? 0, 1, 0, 0, 1. Now our end is pointing to here, our start is pointing to here, right? Now how we can negate these particular chunks from our answer? If we are do so, then our job is done. So how we can do so? So our what is from starting, what is the extra we have added? So that is of our end plus 1. So that is our end plus 1, and if what is the size we are considering from here? So from end plus 1, if can you remove a size of k, if can you remove a size, so that means your end is pointing to this particular end, and end plus 1s, that means this particular chunks we are calculating for end plus 1, and can we go back to k upfront minus k upfront plus 1, because we are considering the circles till end, and as we are doing the zero based indexing, we have added to extra things, and from these extra things that is on the one based index, we are going back to a k upshift, and we are adding what is the size we are getting here, from starting. If our from starting, so that is what is the starting elements. If this, we are basically trying to figure out what is the starting elements of the very end of our particular circle end to a k upshift. What is the starting point of our particular circular things? So if that is of 0 or that is of 1, so that many extra things we have to negate out. So that means here you can see our end plus 1 is basically pointing to a size of 3. So we are here of size 3, and what is the size is given to us? 3 minus 3, k is given to us 3. So 3 minus 3 is given to us of we are able to land on the index 0. So that means from index 0 there is a k group elements exist. So that means we have to add plus 1 to our answer, because from 0 we are able to expand. But if it is negative minus 1, then minus 1 plus 1, so that is going to be 0. So if we are going to be land on a 0 minus 1 index, then we are stating, so 0 basically stands for from index 0 we are able to expand of a group k. It is going to be signifies these things. So that means starting from index 0 we have already expanded to a group of k elements. So can you please consider that group? How you can consider? plus adding to 1 to your answer. So that means considering that particular index, we are able to expand to group of k. So that many group, considering from this can be of starting from 0, this can start from 1, that can be start from 2. So these groups starting from 1, starting from 2, starting from 3, these groups we try to eliminate, if we are do so, if we are able to find from starting how many groups from starting we already have it. We found from here, our case 3 minus 3 is going to be cancelled. We have already a group 1. Which is the group 1? This is the group 1 starting from 0 1 0, that is the group 1. So what we have calculated to our answer, we just do a from starting negation. So that means we will do this particular group to be eliminated to our final answer. So that's what we did. So here you can see we did similar things. We just have to what is from starting, basically n minus k plus I am writing that only n plus 1 minus k plus 1, so that is going to be n minus k plus 2. So here I directly wrote it n minus k plus 2. So that is the from starting this many groups we already calculated. So if we already calculated, please negate it out from my answer, and if we are able to do so, then what is the final answer we have it, just return it out, Yeah, that's all about the today's question explanations. Now let's jump on the time complexity. So the time complexity is going to be super simple. So we at max, this loop is going to be iterate of size what? Size of n. This is two basically chunked loops. So these chunked loops can at max iterate of size n, and again these loops can at max iterate of size n. And here we are not iterating anywhere by OK and other stuffs. We are just calculating our answer. So so every element at max can be visited by one on the circular loop if exists, and if not a circular loop, that is the for sure of big of n complexity. But if there is circular things exist, then we are expanding what is the circle start and end. What is the circle start and end? So for that we have to iterate big of n at worst case. At worst case we have to iterate. So our time complexity is big of n for circle if there is a circle exists, and big of another n when we are basically individual chunks calculations we are doing. So the final time complexity is big of 2n. And space complexity, are we using, do you guys feel, are we using any space altogether throughout the question? We are not, right? We just initialize our start and end, we have variables, we have size, I, etc, etc, etc. Do you identify any extra space we are using throughout the question? No, right? So our space complexity is big O of 1. So the final time complexity, we from big of n cross k, we are able to jump on a time complexity of linear time complexity. So that is of big of 2n. Yeah, that's all about of today's question. And if you understood till this point, please do subscribe to our channel, and please hit the like button, and please turn on the notifications to get the notifications when we are going to update further contents. And yeah, just a quick update, we have also planning to start off job posting updates. So that is basically help all of you guys to, if you don't have the strong LinkedIn connections, or if you are not active on social media, then I will do for your behalf. I will, from my reach, I will find the fruitful post or fruitful job links, and I will make a quick video on that particular job links. Just please make sure you are very agile, very quick. Just please quickly go to that particular job links, and please do the applies then and there. So for that you have to turn on the notifications for that particular job updates video. Yeah, so that's it for today's guys. Let's meet tomorrow with another new questions. Bye.